Alright, so this section, if you look at the homework assignment, it looks like there's a lot of problems, but it's really not that bad because a lot of them are just multiple choice and will only take you just 30 seconds or so to think through them and pick the right answer. So it's not as bad as it looks. Okay, so don't panic when you see we've got 19 questions on there. Okay, in this section in 2.6 we're talking about transformations of functions, and what that means is we're going to talk about moving the graph around. Alright, so if we want to move the graph of a function to the right, how do we do that? If we want to move it to the left, how do we do that? If we want to flip it, how do we do that? And so we're going to talk about a few different ways that we can change the graph of a function. Okay, so the first transformation we're going to talk about what we call a vertical shift. Okay, so we're gonna start with just some generic function f of x. Okay. Alright, so that's our starting function. And then if we have f of x plus some number, alright, so we'll say like plus 2. What that's going to do is that's going to shift our function vertically. And since it's a plus 2, it's going to be shifted up 2 units. So if it's got our function plus some number, that means it's going to move our graph up however many units we're adding to our function. If we have some function and it's minus some number, okay, it's probably just what you'd think. That means our graph's going to be shifted down however many units it says. So this graph would be shifted down 3 units. Okay, so our function plus a number shifts it up, our function minus a number shifts it down. So what are we talking about here? So let's think about the graph of something like x squared. So if we just have x squared, remember it's kind of got this U shape that we call a parabola. Alright. So what about if we had, instead of f of x equals x squared, we had f of x equals x squared minus 1? What's that going to look like? Well, instead of starting down at 0, it's going to start down here at minus 1. So it's going to be shifted down 1 unit. Okay. Or what else could we do? We could do f of x equals x squared plus 3. Okay, so what's that going to do to our graph? Instead of starting at 0, it's going to start 3 units up. Our graph would look something like that. Right? So if we subtract a number from our function, it shifts it down. If we add a number, it shifts it up. Okay. The second way we can transform these functions, okay, is moving left and right. So for those, we call them horizontal shifts. And to me at least, it might not be this way to you, but to me at least, we're going to start with f of x again. Okay. To me, these seem kind of backward. Okay, so what if we have f? The difference between vertical and horizontal is that here, when we're doing the horizontal shift, our plus a number or minus a number is going to be with the x. So we'll have like x minus 7 inside the parentheses there. Okay, so we know I've given away it's going to be shifted horizontally, but which way, left or right? Here, when we do minus 7, it might seem kind of backward, but this is going to be shifted to the right 7 units. Okay, to me, when you have minus 7, you would think it would be to the left, but if you work it out, and if you do like a table of values, it makes sense. But just thinking about minus 7, you kind of have to think backward. Okay, so minus 7, we're being shifted to the right 7 units. Okay, and we can also go the other way. We can go to the left, so there we would have something like f of x plus 2 inside there with the x. So that would be shifted this time, even though it's +2, to me that seems backward. You have to kind of think backward, but that would go to the left 2 units. Okay. So let's think about the graph again, and we'll stick with f of x equals x squared for right now. Okay, so here's x squared. Something like that. Okay. So what if we do a horizontal shift? What if we have f of x equals, and this time our plus or minus number is going to be with the x. So what that looks like is we'll have parentheses and then like x minus 3 squared. Alright, so the minus 3 is on the inside. Okay. So minus 3 inside there means we're going to shift to the right 3 units. Right? So there's our 0, 1, 2, 3. So what's our function going to look like? It's going to look something like this. Right? It's shifted to the right 3 units. Okay. And then if we go to the left, we might have something like f of x equals x plus 1 squared. So that would shift us 1 unit to the left. So then we'll get something that looks like this, right to the left 1 unit. Okay. So those are vertical and horizontal shifts. Okay. What else can we do? Well, the next thing to talk about is flipping our graph, or the more mathematical term, or reflections, right, like in a mirror. So again, if we start with our original function f of x, then one way we can flip our graph is to put a minus sign out in front of the whole thing. So we make just put a negative in front of the whole function, and then we have to think about how this is going to be reflected. Well, everything that was positive is going to turn negative, everything that was negative is going to turn positive, so we're switching the y values is what we're doing. So this is reflected over the x-axis. So top goes to bottom, bottom goes to top. Okay, so let's go ahead and talk about one of those. So we'll stick with x squared here. So we do x-axis reflection. Okay, here's f of x. And then what about if we have f of x equals negative x squared? Well, it's just going to be reflected over the x-axis, so it's going to point down instead of up. Okay? And they'll look exactly the same, otherwise mine look a little bit different because I'm just hand sketching them really quickly, but they'll be exactly the same except one will be going up, one will be going down. Okay? Alright, there's another type of reflection. We can also reflect over the y-axis. And the way we do that is we make the x inside the parentheses negative. Okay? So here, f of negative x, it's reflected across the y-axis. So what we're doing here is we're changing the right side goes to the left side goes to the right side. Okay. So let's look at one of those. I'm going to switch functions here because if you can look, if we did x squared and we switch left and right, it's symmetric, so it's still going to look exactly the same. Okay, so let's do a different function here. What about f of x equals x cubed? And you remember what that one looks like. It's going to come in something like this. So here, if we do f of negative x, okay, what's that going to look like? Well, we're switching the left and the right side, so instead of coming in on the left side, it's going to come in on the right side. and it'll look like that. So this stuff goes over here, this stuff goes over here, and we're reflecting it over the y-axis here. On this last one, top went to bottom, and we reflected over the x-axis. Okay. All right, and then one more type of transformation here. Okay, and that's when we have a stretch or a shrink. And here we're talking about in the vertical direction, so up and down. So if we start with f of x, okay, start with f of x here. Okay, so the way we would stretch this is we would say that 4 times f of x, 4f of x, is stretched by a factor of 4. And the reason why we know this is a stretch, because the number we're multiplying by, 4, is bigger than 1. So that means this is a stretch. This right here means it's a stretch. So what if the number we multiply by is not bigger than 1? So, okay, well, let's think about 1/4 f of x. So that's not bigger than 1. And then that is going to be shrunk, I guess, or compressed. Okay. That's going to be shrunk by a factor of 4, because we're kind of dividing by 4. All right. So what's this going to look like on the graph? Okay, so if we have f of x equals x squared. Okay, so there's our starting function. Okay, then if we do 4 times that, let's do a different color, sorry. If we do 4 times that, we'll have f of x equals 4x squared. So this is going to be stretched, okay? And the way it's going to be stretched, you can think about it kind of like a rubber band. It's going to start here, and it's going to be skinnier, and it's going to go up faster. Okay? So this is going to be stretched. And if we did a shrink or compression, it's like if we have 1/4 x squared, and it's like it's not a technical term, but it's like it's squished. Okay, it's going to be kind of short and thick. Okay, it's like we're pressing down on it. Okay, so that would be our shrinking or our compressing of our function there. Okay. And the other thing to talk about here is that you can do more than one of these, right? You can do more than one of these. So let's look at a different function. Let's look at, think about our function absolute value of x. And you can think really quickly about what its graph looks like, right? It's the V shape. Right. So what if we had a new function? What if we started with absolute value of x and we ended up with this? Right. So, and I should have written that in red, but we'll just say this is going to be our red graph. Well, what's happening on that? Well, this tells us that our graph's going to be shifted right 3 units. And then this tells us that it's out on the outside that our graph's going to be shifted up 2 units. So our graph is going to go over to the right 3 and up 2, so the pointy part's going to be right here. We're going to get this graph. It would be our new graph. Right. So the part inside the x, that's left and right, and the part outside, that's up and down. Okay, and we didn't have any reflections on this one. We didn't have any compressions or shrinking. I mean, stretching or shrinking. Okay. So that's all this section is, okay, is dealing with different graphs, some of the ones we talked about, like square root of x, x cubed, absolute value of x, x squared, talking about those basic functions and looking at transformations done to those. If you have any questions, let me know.